Okay, everyone. Hello, welcome back to my colleague's AP Chem FRQ final review. This will be our last video. So today we're going to look at 2013 AP Chem FRQ question 2. Let's first pause and read the question. Okay, so the first question, we know the information that an electrolytic cell produced 235 grams of aluminum according to the equation above, and A is asking us to calculate the number of moles of electron that must be transferred in the cell. So before we need to calculate the moles of electron, we need to calculate the moles of aluminum. In order to calculate that, we take the molar mass, and which is 235 gram aluminum over, not times, it's over 26.98 gram aluminum. Then we get 8.71 mole aluminum. Since we have 4 aluminum in there, or actually we take the equation, yes, the nylon equation, Al3 plus 3 electrons become aluminum, and so we have 3 electrons in there. We will take 3 times 8.71 moles. So thus we will get 26.1 mole electrons. And let's all look at question B. Let's first erase question 1, question A. So question B is asking us the amount of time in second that was needed. In order to calculate this, we will have to use the other formula, which is charge is equal to moles electrons times Faraday number. So the moles we have is 26.1 mole electrons, which we get from question A, and the Faraday number is 9.65 times 10 to the 4 C over 1 mole. Eventually, we get an answer of 2.52 times 10 to the 6 C. And for part C, it's asking us to calculate the volume of carbon dioxide at 301 K and 0.925 atm. Okay, so first, when we calculate the volume, we need to figure out how many moles of carbon dioxide is produced during the process. So how do we do that is we use the molar ratio. The aluminum we have is 8.71 mole, and we would times 3 over 4. The answer would be 6.53 mole of carbon dioxide. Then we need to use PV equals nRT, that great equation, to get the volume. Since the only thing we don't know is volume, we put everything on the right side, which is volume equals nRT over pressure. So 6.53 moles times 0.0821 liter atm over mole K times 301 temperature, 301 K, and on the bottom is 0.952 atm. The answer would be 1.70 times 10 to the 2. liter of carbon dioxide. That is how much is produced in the process. Then let's look at question D. For the electrolytic cell to operate, the Ol2O3 must be in liquid state rather than a solid state. Okay, let's take a pause and think about this question. Okay, so the reason why is because when it's an ionic compound, solid state will not transfer electricity, only electric state, so that ion will be mobile and able to move to transfer electricity. Then let's look at the question E. So in question E, it's asking about how to calculate E, which is in volts. Let's write down the equation, which is cathode minus the anode. And usually we always take the highest number as our cathode, which is minus 0.83, and we plus 2.35 in this case. So which will get a number of 1.52 voltage. And for the last question, it's asking about calculating delta G. We're going to use the equation of delta G is equal to NFE, negative NFE. The most we have is from the question A. Oh, actually, no. The N we have here is the lowest number to cancel out each other the electrons, because when they are cancelled out, you can calculate them. So in this case, it's 6. And we times the Faraday number, then we times the voltage we get from I. And the final answer will be negative. So this will be our final answer. Okay, thanks everyone. This is my final video. Hope you all have a great AP Chem test.